two videos. This one is on that little review. I know there are some topics that you might see there that we haven't covered, but it's okay. You get a preview. I'll give you eventually another preview review sheet, but you can start with this just to see what kind of topics are on the test. All right, so let's make this really quick. All right, so I know there's some sixth grade topics. I'm not a big fan of that. But here, Best Buy. If this is a multiple choice questions, then you can be a little bit relaxed about it. If it's not, make sure you write your units. So we have 18 songs here. What do you have here? 2235 for 28 songs. And what's the last one? 54.9 for 45 songs. We want the unit rate. Remember, unit rate. So I want to know how much is one song in that package, how much is one song in that package, and how much is one song in that package. So we're simply dividing, right? 23 divided by 18, remember. And here, rounded, it's $1.28 per song. What is this? 22.35 divided by 28. Did I get this right? And here is a little bit cheaper. Again, we're going to round this. It's 80 cents per song. And the last one, 54.9 divided by 45 songs, it's $1.22. So the best value, or the best deal in this case, is here, right? So this gives you the better price per song. Okay, so you definitely will see some of these, again, unit rates, complex fractions. I mean, nothing, no big deal. What is it? So we're gonna write that as a, what do you call, as a fraction always. So 2 3/5 inches of rain per 7/8 of an hour. My suggestion to you is you have a calculator. So I mean, if you have a calculator, everything goes down the drain. But if you don't have a calculator, I would rewrite this, right? So we're going to write this as 13/5 of an inch, 13 over 5 inches of rain in 7/8 of an hour if you didn't have a calculator. But that's not the case. Now we're going to change this to how much rain it gets in 1 hour. So we multiply it by the reciprocal. Multiply that by reciprocal. And that's why I changed that to a, an improper fraction here, because it's so much easier to multiply than multiply by a whole number. So at the bottom is just 1, and on top we get 13/5, and I guess we got 13 over 8, 13 over 5, times 8 over 7, and we get 2 and 34 over 35. And do we want to do something? Yeah, we want to do something in there. So we get 2, 34 over 35 inches of rain in 1 hour. Okay, and if I want to know how many inches of rain came in 8 hours, I'm just going to take that, right? And now I multiply that by 8, and I obviously have to multiply the top by 8, and I'm going to split that. And we get 23 inches and 27 out of 35. 23, 27, 35 inches of rain in 8 hours. Okay. All right, so again, pretty straightforward. This is Quilton Northern 30 roll toilet paper. So if you buy 30 rolls of toilet paper at Costco, so let me write that as a fraction here. So $24.99. We get 30 rolls. Each roll, if you unroll it, it covers 18.33 square feet. So how much do you end up paying per square foot when you buy the 30 roll pack? All right, so if I have 30 rows, so one row covers an area of 18.33 square feet. Okay. If I have 30 rows, I multiply that by 30. So 30 times 18.33 equals, so 549 square footage. So I'm going to rewrite my fraction here, and I'm going to write for $24.99, I can cover this much, 549 square feet, which is about the size of a lot of apartments in Manhattan. But I'm interested to see how much 1 square footage, how much is the cost for 1 square footage. So I'm going to change that to unit rate, and instead of 549.9, we're going to write 1 square foot. How do I do that? Well, right, we're just simply going to divide top and bottom by 549.9, 549.9, and 549.9, and that's going to give us 24.99 divided by 549.9, rounded, by the way. Every square foot, 0.05 cents. So let's think of a tile in your classroom, like, you know, if you look at the floor in the classroom, like one of those square tiles, that's about a square foot tile. So every square foot of tile, every area of that size is about 5 cents. Okay. But find the unit rate of a jogger whose speed is 2/13 of a mile in 1 minute and 45 seconds. So it's always easier if you write it as a fraction. So let me, can we expand this? I think when I don't have room. So let me write this 2/13 and write your units of a mile in a minute and 45 seconds. But it doesn't say what the unit rate here is. It the unit rate in minutes, in hours? So I'm going to put it in a minute 45 seconds. I'm going to put that as, so a minute is 60 seconds, right? And 45 seconds, so that would be 105 seconds. 105 seconds, or better yet, if we want to find, let's not go to seconds because that's going to be too much of a, too small of a unit. So let's go by minutes, I guess. So in terms of minutes, 1 minute and 45 seconds, we can write it as 1.1 and 45 over 60. Okay, which we can obviously write it as 1 3/4. So 1 3/4 of a minute. So let's write it that way. So he can run 2/13 of a mile in 1 3/4 of a minute. Now, if you want to change the unit rate to, let's see how much he can run in just a single minute, right? So let's change that 1 3/4, and we can write 7/4, right? Because it's the same thing. So that helps me because now I know what the reciprocal is. And the reciprocal of 7/4 is 4/7. I'm going to multiply top and bottom by 4/7. And I'm going to get 8 over, what is that, 21, 91. So in 1 minute, he can run 8/91 of a mile, which is not that far at all. Really? That seems very little. Okay, well, it is less time than 1 3/4. So that's your recall. That's your answer. 5. Adam ran the 100 meters in 14.2 seconds. He continues. How far could he run in 40 seconds, assuming he kept the same pace? So again, I guess we need the unit rate per second to then multiply. So again, 100 meters. Let's write this out. It's 14.2 seconds. All right, let's find the unit rate, because the unit rate is going to help us. So how far can we run in 1 second? So divide both top and bottom by 14.2. 14.2. Oops. Divide by 14.2. We get 100 divided by 14.2 equals what? 100 divided by 14.2 equals, we're going to round this to 7.04 meters per second. Okay. And now if I want to find out how far he's going to run in 40 seconds, that's easy, right? I'm going to write it. So this we're going from rate, and then we found our unit rate. The reason we find our unit rate is because it's going to help us with our prediction. We want to predict how far he's running in 40 seconds. So we have our time, right? So we have this, that we know that in 1 second he covers 7.04 meters. It's just a question of multiplying by 40. So 7.04 times 40 equals 281.6 meters. And that's how far he would run. 7. What? Okay, so we just did this. Let's match the corresponding side. So let's see. Remember that this rectangle is sideways, so be careful with that. So this side, the corresponding side in the smaller rectangle would be this. And this side, right, the corresponding on the smaller triangle with that. So let's write our proportion. Let's call this new and let's call this old. Doesn't really matter. So x, the ratio of x with its corresponding side, which is 8, should be equal to the ratio of 57 with its corresponding side, which is 24. Cross multiply, we get 24x equals 57 times 8, which is 456. We're going to divide by 24. We got to divide by 24. We get x equals 19. Okay. Tallest tree. Okay, so let me just put this. Tallest tree in the United States, a coast redwood in Jediah Smith State Park, California. Yep. So here's a tree. The height is 320 feet tall. Okay, suppose you are 5 feet 8 inches. So here is you, and you're 5 feet 8 inches. Okay. And you cast a shadow, and your shadow here is 2 inches. We want to know how long is the shadow of the tree. Okay, here's the shadow of the tree, which we don't know. So the problem here is that this is 5 feet 8 inches, this is just 2 inches, and this is 321 feet. So we got to change everything to either just feet, obviously, not sorry, to inches. It's just going to make life so much easier. So instead of saying 5 feet 8 inches, we're going to say 5 times 12 is 60, right? Because 1 foot is 60 inches. 5 times 12 is 60 plus 8. We're going to call this 68 inches. So you're 68 inches tall. All right, so this we're going to cross out. We're going to write it like that. And the tree is 321 times 12. And the tree is actually, we're going to rename this as 3,852 inches. That's how tall that tree is. So now we're going to write our proportion. So much easier, right? So this, the height of the tree, which is 3,852, the ratio of that with your height, which is 68 inches, is equal to the shadow of the tree over your shadow, which is 2 inches. Okay, so obviously this would have been divided by 34, but we're just going to cross multiply this. So we get 68x equals 3852 times 2, which is 764. No, sorry, 3852, sorry. 3852 times 2, which is 7,704. We're going to divide both sides by 68. Divide that by 68. We've got to divide that by 60. So the shadow is 113.29 inches. The shadow of the tree is 113.29 inches. Okay. 7. Oh, that's nice. Diagram below, large flat post. Okay, marked below. He even looks at 16. Okay, blah blah blah. Flag post 5 meters tall. Marked case is 110 from the building. How tall is the building? So we want the height of the building here. Okay, all right. Not a big deal. So let's separate these two triangles. Okay, so we're gonna get that. We know this is 60. The flagpole is 35. And then we have the bigger triangle. The height of the building is what we know. We want to know. They're calling that h. That's fine. And that distance here is 170 plus 60, right? 170 plus 60, which is 230. So let's identify our corresponding. So this corresponds with this. That corresponds. Oops. This corresponds with that. So we can set up a proportion. So proportion, let's go with, I'll call this new and old. So 35, the height of the flagpole, the ratio of that and the height of the building is equal to the ratio of the shadow of the pole with the shadow of the building, which is 230. Cross multiply, we get 60h equals 230 times 35, which equals 8,000. Oops. Which equals 8,050. And we're going to divide both sides by 60, and h equals, and we're going to get round 134.17 meters. Okay. Again, Malik standing outside in the sun. He's 72 inches tall. That's him right here, 72 inches tall. And his shadow is 60 inches. Okay, so I'm going to make the shadow a little smaller. So here's his shadow. Okay, inches, by the way. And Jeremy's standing near Malik. Jeremy is 50 inches. Jeremy's shadow, so the other kid's shadow. Okay. Let me make this shadow a little bit smaller. That's his shadow. And we want to calculate his height. So we want, okay, so this is Malik. No, this is Jeremy, sorry. This kid over here is Malik. So we want to use, again, the proportion to find out the height of Jeremy. So that would be the picture. So let's, again, it's pretty obvious who's corresponding. So let's call Jeremy's height h. So 72, which is the height of Malik, corresponds to the height of Jeremy. And Malik's shadow, which is 60, corresponds to Jeremy's shadow, which is 56. There's our proportion. 60h, cross multiply. 72 times 56 equals 4,032. Divide. Why does my pen keep doing that? Sorry, guys. Divide 4,032. Divide both sides by 60, and h divided by 60, and h equals, what is it? 67.2. So Jeremy is 67.2 inches tall. Figure to the right, triangular similar. What's the value of x? Okay. So corresponding sides. Let me move this up again so I can do 4 at a time. Oops. Okay, right there. So corresponding sides. This matches with this, and this matches with this. The other two also matches, like right the base of the triangle, but I'm not interested in that. So I can set up my proportion, and let's use a smaller. So the ratio of 6 to x equals the ratio of 5 to 11. Cross multiply, 5x equals 66. Divide both sides by 5, and x equals 66 divided by 5, and x equals 3. Oops. 66 divided by 5, x equals 13.2. Okay, so 7 pounds, so let's call this 5.95 for 7 pounds. This week the pounds are the same, the price is the same, he wants to buy 5 pounds. So again, we can find the unit rate. So we go from this, find how much is 1 pound of apple. So 5.95 divided by 7, that's going to give me 85 cents per pound. Now if I want to find out what 4 pounds equals, look how simple that is. Times 4. Times 4, 170, $3.40. And that's what he's going to pay this week. Rectangle is 12 meters long. Oops. 12 meters long, 20 meters wide. What dimensions correspond to a non-similar rectangle? So let's draw them out. So is, let's see, let's try the first one out. First one, 4 meters long and 7 meters wide. Right? How does a 12 become 4? Divide by 3. How does a 21 become 7? Divide by 3. Are these two similar? Yeah. Second triangle, second rectangle. This is 8 and this is 14. Okay, so what we have to do is I'm trying to figure out because I need to worry. 12 divided by 8 1.5. So if I divide 12 divided by 1.5, it gives me 8. So this one is divided by 1.5, gives me 8. And 21 divided by 1.5 is 14. So again, similar, right? Because the proportions are equal. So the next one we have 30 and 35. And again, oh, I see. So we can, did I make this? Sorry, let me make my rectangle. So you can set up proportions. This is 30, this is 35. So we go 12 to 30, right? The ratio of this to this should equal to the ratio of the width, which is 21 over 35. So if you cross multiply 30 times 21, you get 630. And if 12 times 35 is also 630, which is not, this actually equals 420. You can tell that these two are not the same, therefore these two rectangles are not similar. So C, where did I get 30 and 35 from? Sorry guys. 12 and 21, it's supposed to be 20 and 25, I apologize. Okay, so sorry, 20 and 35, and again, so let's set up proportion. So 12 to 20 should be equal to the ratio of 21 and 35. So again, 12 times 35 is 420. Okay, and 20 times 21 is also 420. So this was similar, that was similar, that was similar. So the last one is not a similar rectangle, but let's just prove it out. So we get just 24 and 35. So this one is obvious. So if you look at this, how does the 12 become 24? It's times 2. How does 21 become 35? Definitely not times 2. So let's use a proportion to prove it anyway. So the ratio of 12 to 24 should equal the ratio of 21 to 35. So we can cross multiply here. 12 times 35 equals 420. And 24 times 21 is definitely not 420, it is 504. So D is the one we were looking for. Oliver reads, how much does he read in an hour? Okay, so again, 32 and 1/5 pages in 1 3/8 of an hour. That's how long. But I want to know how many pages he reads in just 1 hour. So that's our unit rate. And again, I want to change this to an improper 8, 1, so that becomes 11 over 8. Right, so now I know what the reciprocal is, which is 8 over 11. And I multiply that by 8 over 11, multiply that by 8 over 11. And you get whatever you get, which, according to your calculator, which I hate using, 32 and 1/5 times, what is it, 8 over 11? Equals, so in 1 hour, he actually can read 23 pages and 23/55 of the next page. So that's his unit rate, right? Determining whether the ratios, I think the question was, are proportional. I made a mistake, are proportional. Okay, so one way you can determine if two ratios are proportional is setting a proportion, and if they're equal to each other, then what do you call? They are proportional. So where's my pen? So 8 over 12 and 10 over 18. So if you don't like to cross multiply, we can simplify this. We simplify 8 over 12, we get 2 over 3. If we simplify 10 over 18, let's say divide by 2, we get 5 over 9. It is clear that 2/3 is not the same as 5 and 9, right? So obviously we know this is not proportional. Now that's one way, and the other way would be to cross multiply. And if you can cross multiply, 8 times 18 equals 144, and the other one you get 120. And again, because they're not equal, they're not proportional. So You can either do it this way or do it that way. The scale. So if you look at a map, there's always something here at the bottom of the map, right? And there's a little scale, and it's telling you that 1/4 inch equals to 18 miles in real life, right? So every 1/4 of an inch on that map is 18 miles. So the state capital is 252 miles from the border. How far is the state capital border on the map? So in real life, we're going to set a proportion. In real life, the state capital is 252 miles from the border. How many inches would that be on on the map? So 1/4. So let's write that ratio, right? 1/4 inch is the same to 18 miles on. That's our scale. So 252 miles. How many inches would that be? I'm going to call that x. Oh, we can cross multiply. X times 18 is 18x, and 1/4, so we can go 252 times 0.25, multiply by 1/4, whatever you want, which is 63. Now divide both sides by 18. And on a map, that distance would be 3.5 inches. Okay, that's it. So I got a preview of your test. Okay, so these are the topics on Unit 5. As you can tell, they're very simple.